Precipitation. Drizzle is very small drops of water which appear to float. Freezing drizzle is that which freezes on impact with objects. Snow grains is frozen drizzle, which are very small white opaque grains of rice in appearance. Snow pellets, the precipitation is of white and opaque particles of ice, spherical or conical. When they fall on hard ground they bounce and often break up. Hail is lumps of ice, generally showing concentric layers of clear and opaque ice. Snow is white or translucent ice crystals, usually of branched hexagonal or star-like form, frequently interlocked to form large flakes. Rain is precipitation of water droplets, which are larger than drizzle. Freezing rain is rain that freezes on impact with objects. Ice pellets is frozen rain, which are transparent or translucent pellets of ice that are spherical or irregular. They usually bounce when hitting hard surfaces and make a sound on impact. The precipitation processes. Theoretically, it's conceivable that water vapour might condense onto water droplets in cloud, gradually increasing the droplet size until raindrops are formed. However, in reality, raindrops form at a faster rate than this theory would support. The precipitation process is thought instead to occur by two other means, namely the ice crystal effect, Virga and Thunderstorm process, and the coalescence theory, or capture effect. Both these theoretical processes may produce precipitation either individually or together. The ice crystal effect, Virga and Thunderstorm. In a cloud of great vertical extension, water may exist as a mixture of supercooled droplets of varying sizes at temperatures below 0 degrees Celsius, and as ice crystals. Due to the difference in saturation vapor pressure between ice and liquid water, water vapor tends to sublimate onto the ice crystals. The growth of the ice crystal may be so great that some freezing water droplets evaporate. As a result, many different kinds of ice crystals start to fall down through the cloud at about 0.5 meters per second. These falling ice crystals are colder than the ambient air, and condensation and more sublimation onto the ice crystal may occur. More water droplets and ice crystals may collide, forming aggregates of ice crystals called snowflakes. Their rate of descent is 1 to 2 meters per second. The difference in saturation vapor pressure between ice and water is greatest around -12 degrees Celsius, and clouds at this temperature produce precipitation. Coalescence, or the capture effect. The idea of the theory is that the cloud droplets will collide due to the vertical mixing in the cloud. Clouds formed over the sea in warmer latitudes contain large amounts of water vapour and salt particles from the sea. Salt is a hygroscopic substance, i.e. it is highly water absorbing, and cloud droplets containing salt particles as condensation nuclei have the capacity to grow. These heavier droplets start to fall, collide with other drops, and thus grow even larger. If the cloud is thick enough, the cloud droplets have time to grow into raindrops, whose size in turn depends upon the intensity of the updraft in the cloud. Hail, GS. Various types of hail sometimes form, depending on the size of the updraft and the water content of a CB cloud. Snow pellets or graupel. These form in CB clouds with low temperatures, small droplets and comparatively high updrafts. This often happens when the CB clouds form in cold air sweeping down with northerly or northeasterly winds over Western Europe. The hail is less than 5 mm in diameter. Small hail. This forms when snow grains come down in the part of the cloud where there are major droplets, which can spread a coating around the snow grain before it freezes to a smooth layer. The size is about the same as that of a snow grain, but the grain is somewhat heavier. Graupel and small hail pass under the international designation Grezil and are abbreviated GS. SHGS would infer showers of graupel or small hail. Hard hail, GR. Hail forms by deposition of water onto an ice crystal by the Virga and Thunderstorm effect. When a cloud contains vertical updrafts stronger than 10 to 15 meters per second, and the 0-degree isotherm is well up in the cloud, say about 7 to 10,000 feet. Hail typically forms from a CB cloud. Hail has the designation grêle and the abbreviation GR, where showers of hail would be SHGR. Formation of cumulonimbus clouds. The initial stage of a CB contains mainly updrafts. The mature stage contains updrafts and downdrafts, and the anvils beginning to form. The dissipating stage of the CB will contain the anvil and will primarily have downdrafts. Thunderstorms. In order for the development of a thunderstorm, 3 factors have to be present: a lapse rate greater than the SALR, i.e. an unstable atmosphere, a good supply of water vapour, and a trigger action, for example convection or orographic uplift. Thunderstorms are normally produced in a well-developed CB, but not all CB clouds have thunderstorms. Thunderstorms are classified as frontal type thunderstorm, which is a winter phenomena over land or sea, by day or night, usually formed at the cold front or occlusion, or at depressions and troughs. These can move very fast. Or a heat type thunderstorm. This is a summer phenomena, frequent over land by day, clearing by night, usually forming in cols and weak depressions, and are fairly stationary. Thunderstorm development. The initial or developing cumulus stage takes about 20 minutes. The mature stage lasts for about 40 minutes, and the dissipating stage takes up to about 2 hours. Thunderstorm facts. A gust front is formed by a cold airflow out from the thunderstorm. Thunderstorms move in the direction of the 700 hectopascal flight level 100 wind. Thunderstorms produce static, which causes interference with radio equipment. The highest frequency of thunderstorms encountered occurs in tropical air masses. St. Elmo's fire can be caused by static, resulting in purple rings of light around the aircraft wingtips and nose surfaces. Avoid thunderstorms horizontally by 10 nautical miles from ground level to flight level 250, 15 nautical miles from flight level 250 to flight level 300, and 20 nautical miles above flight level 300. Clear the tops vertically by at least 5,000 feet. Pressure areas and squalls. A trough is an area and part of a low pressure system which is elongated on a pressure chart. A ridge is an area and part of a high pressure system which is elongated on a pressure chart. A col is relatively calm air between high and low pressure. A squall is a storm line. There's a lifting action of a cold front which could be an obvious trigger for a thunderstorm. In summer these are well ahead of a cold front in an organised line called a squall line. Frontal, trough and line squall thunderstorms tend to be close together and more intense, making flying around them impossible. Virga, fall streaks. Virga is precipitation which does not reach the ground. It's an indication that a microburst exists aloft. The microburst. A microburst is a cold downburst of air that lasts 1 to 5 minutes and is approximately 5 kilometers wide. Microbursts are associated with severe convective activity, typically with CB clouds and thunderstorms. Pressure will rise at the surface underneath the downburst. An aircraft approaching a microburst gains energy, shows an increase in airspeed, and rises above the glide path. Underneath the microburst, energy will be lost in a downdraft. After the microburst, in the increasing tailwind situation, the aircraft will sink from the sky. There's a horizontal wind shear over distance. Thunderstorm facts. Ahead of the thunderstorm is a gust front and possible roll cloud formation. This will be a very turbulent area to be flying in. Pressure systems. In this diagram you can see high pressure, where the centre of the enclosed isobars has higher pressure, and away from the high pressure is low pressure centres. An elongated ridge of high pressure exists, and an elongated trough of low pressure exists. Between the two highs and the two lows, a coal is present. There's also a secondary low which will be circulating around a primary low.